So let's look into law of refraction, not reflection, refraction. So the first part of the law talks about the incident ray, the refracted ray, and the normal to the interface of the two transparent medium and the point of incidence all lie in the same plane. So we saw a similar thing in law of reflection, the second part of it. The incident ray, the normal, and the reflected ray all lie in the same plane. It's the same thing. We're talking that imaginary plane in which all of them lie. I hope you guys understand this. If you understand the second part of the law of reflection, then this will make sense. So please understand this first and this will make sense. So I'm not going to detail of that part, but second part we'll be looking into with examples. Okay. So the second law talks about ratio. Ratio means what? Division. So division between what to? Sine of angle of incidence to the sine of angle of refraction. And this is equal to a constant. Sine of angle of incidence by sine of angle of refraction is equal to a constant. Okay. So this is your incident ray, this is your refracted ray, this is your medium 1, and that's your medium 2. Right. So for a given medium, there is a condition for the light of a given color and for a given pair of medium. So medium 1 and medium 2, if it's fixed and the light is fixed, whatever the angle of incidence is, the angle of refraction will be such that if I take the sine of it, that will be equal to constant. So if there is a question about sine, what is sine? Sine has to do with something called as trigonometry. Okay. So if you open your scientific calculators, right, you'll get a trigonometry section wherein you have sine, cos, and tan, sec, cosecant, cot. These are your trigonometric ratios. So if you are not done with trigonometry chapter, then you will not understand this to that extent. Actually, you won't understand it at all. Okay, so you finish that and this will make sense. So let me show you guys an example that what we're talking about is actually true. So we'll actually be taking up the practicals which we have done and looking into these values. So all this law tells us if I happen to fix the color of the light, okay, so that is also important, and the mediums, then the ratio of sine of angle of incidence to angle of refraction will always be a constant. So let me begin with the first example. So this is your incident ray, this is your refracted ray, this is air, and this is oil. This I'm going to fix. Okay, air and oil and the light of the color. Wait, light of the color of the light. Okay, right, color of the light is fixed. Now I have a protractor. So this is your normal, and with respect to normal, we measure all the angles. So this happens to be 10, 20, 30, 31. So angle of incidence is equal to 31 degree. Okay, I represents angle of incidence. So yeah, 31 degree. This is around how much? Let me extend this. It looks to be around 21, right? Okay, so this is 10, 20, a bit more than that. You can pause and zoom in if you guys want to. So this is 31 and 21. And this is your normal. The normal are not in the same line because we have a glass slab in between these two mediums. So we'll understand this shift is there. You'll understand this shift in time. But imagine that, yes, we just have air and some kind of very thin transparent medium in which we have the oil. Or you can imagine oil being frozen and you are looking at this setup. Okay, so this is the best I can explain. So these are your incident ray and refracted ray. So if I take sine of 31 divided by sine of 21, what happens? Let us see. So first is you have 31 sine of that. Okay, divided by 21 sine of that. Okay, and the division gives us 1.437, approximately 1.44. The same setup, but let me just a second. Same setup, but yeah, we have an angle of incidence which is a bit lesser. So let's see what happens. So the first thing is the value. It's around 10 and this is around 16, right? You can clearly see 16. If you're not able to see, please take a screenshot or whatever is possible, or zoom in if that is possible. If not, observe it is over there, right? This is 5 and this is 6. And this happens to be, okay, this though I have to extend. It looks to be 10, but I think it's a bit pointing towards 11. Okay. Okay, not exactly there. Okay. Not doing a very good job, but right, we can clearly see it's 11. Right, again, it's okay, a bit of approximation. We are not able to do a exact setup and exact experiment, but this is good enough. Sine of 16 divided by sine of 11. So again, just press 16 and take the sine, divide by 11 and take the sine, equals to, here too it is 1.444, 5 and all of that. So here too it's approximately 1.44. We have this exact value, right? You can see that these two ratios are same, and this is what the law tells. For a given light and given pair of medium, so exact oil and air, any point of time, you anywhere you go and take this and do this experiment, okay, and measure the angle of incidence and angle of refraction, you will get the exact value. And this happens to be a constant, right? And this is your Snell's law of refraction. Okay. The second one is quite important. The first one you guys have a basic idea. So anyways, you guys have to make a note of both. So please pause and write it down. And do write the experiment also. You need not write the compass and all of that, but yeah, let me remove this. Okay, so yes, you guys have to write this down. This is air and this is oil. These are actual values, right? And this is an I forgot which oil is this, but yeah, you can web search for this value, optical density or refractive index, actually refractive index of oil. So you'll get around this value itself, and you can make out which oil also. So which oil is there in this chamber, you can make out this and this. You have to write both the examples.